Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Welcome to Lesson 17, Graphing Quadratic Functions from the Standard form. Okay, so Lesson 16 was graphing from the vertex form. Now we're going to graph from the standard form, which is f of x equals ax squared plus bx plus c. Classwork opening exercise says a high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t equals negative 16t squared plus 96t plus 6, where t represents the time in seconds since the ball was thrown, and h represents the height in feet of the ball above the ground. Okay. So it says, what does the domain of the function represent in this context? Okay, now remember, domain, so if we had an ordered pair, x, comma, y, the x is the domain, and the y is the range. Okay, so now I'm going to erase this, because now we have f of x, which is y, which is here. Now it's h of t. So t is my x, and h of t is my y, if you will. So the domain is t, time, okay, where t represents the time in seconds. So what does the domain of the function represent in this context? And it is, let me just type it, it's easier. It's the time, number of seconds, since the ball was thrown. Okay, time in seconds since the ball was thrown. Let me just shrink that down a little bit. There we go. Okay, so the time, the number of seconds since the ball was thrown. Okay, next problem says, what does the range represent? Or what does the range of this function represent? So let me go back up here. That was a mistake. So the range is your y, and it's h of t, so it's the height with respect to time. So it's h represents the height in feet of the ball above the ground. So the answer is right there. Okay, so the range in this function represents the height in feet of the ball above the ground. All right, part C. At what height does the ball get thrown? Okay, so think about that. So picture a person standing there, and they're getting ready to throw the ball. 0 seconds have gone by because they haven't thrown the ball, but as soon as they throw the ball, the timer starts counting. So in other words, the ball is in the person's hand, and until they let go of it, then that is the height the ball is getting thrown. So if time is 0, so if this was 0 here, negative 16 times 0 squared is 0, plus 96 times 0 is 0, 0 plus 0 is 0, plus 6 is 6. And that is feet. So at what height does the ball get thrown? The ball gets thrown at the height that the constant is, because when t is 0, then we get 6. 0 plus 0 plus 6 is 6. Okay? Okay, so here it is in words. The initial height of the ball is when t is 0 seconds, i.e. h of 0, which is the y-intercept. The initial height is 6 feet. All right, part D. After how many seconds does the ball hit the ground? Okay, so what they're asking is, when is this equal to height 0? So the height after so much time, and so we want to figure out how much time the height is 0. So in other words, we want to set this equal to 0. So it's going to be 0 equals negative 16 t squared plus 96 plus 6. I want to know when what t, whoops, 96t. I want to know when this is going to equal 0. So there's a few different ways to do this. Since a is negative and fairly large, it's kind of difficult to find factors of this. So I think the easiest way would be to complete the square. All right, so first thing we do to complete the square is take that first term's coefficient and move it outside of the parentheses. And then we need to take this t squared plus 96t and find what's a perfect square. So remember what we have to do is, if we factor out a 16 also, then that's not going to be 96. So it'd be 96 divided by 16. And that is 6. Okay. So this is going, I'm factoring out a negative 16, so that's going to come out. And then that factoring out a negative will make this minus, right? Negative times a negative would be positive. Negative 16 times negative 6 would be 96. Okay. And then we have equals, and we're moving this over to the other side, negative 6. So I could have the negative 6 over here, but instead I'll just move it like this. All right, so let me clarify this. So instead of this being equals 0 here, we had equals 0 over here. So negative 16t squared plus 96t plus 6 equals 0. Factor out a 16 and move this constant over to the other side. If you don't remember how to do completing the square, go back and watch that video. So now I have this t squared minus 6. That's not a perfect square, so I need to continue. And it's going to be t squared. There should be a t here, by the way. Minus 6t. And what we do is we divide this by 2. Remember, it's negative b over 2 squared. So it's negative 6, and we're going to divide that by 2, and then we're going to square that. So that's going to equal negative 3 squared, which is 9. So it's going to be plus 9. All right, equals negative 6. Okay, and let me do the plus 9 in a different color. Let me change this color. All right, so we aren't just adding 9 to the left, so I can't just add 9 over here. That would not be correct, because this 9 is being multiplied by this 16. And 16 times 9 is 144. So if negative times a positive is negative. So actually I added a negative 144 to the left. So I have to add or subtract 144 from the right. Add a negative 144 or subtract 144 from the right. Okay. So now I need to simplify this. So it's negative 16 t minus 3 quantity squared would give us this here equals negative 150. Now I'm going to divide both sides by negative 16. Okay, these cancel, and I get t minus 3 squared equals 150 divided by 16, which is 9.375. Okay, so we don't want a decimal, so let's just do this a different way. So it's a negative divided by a negative. So let's just make it 150 over 16 because a negative divided by a negative is positive. All right, and then we're going to take the square root of both sides because I have to get rid of this squared. So if I take the square root of both sides, I get t minus 3 equals the square root of 150 over the square root of 16, which is 4. And it's plus or minus. And then finally, I move the t to the other, or the 3 to the other side, add 3 to both sides, and I get 3 plus or minus the square root of 150 over 4. Okay, so if I put that in my calculator, so it's, this should be, no, that's right, okay. So it's t equals 3 plus the square root of 150 divided by 4. Okay, and that equals, so t equals 6 point, and that was 0.618. Okay, 0.618 or 0.619 if you round it up, but that's close enough. And it shouldn't be equals. I want approximately because we rounded. And then it would be or, and then we want to do the negative. So I'll just hit second enter to save time and move back and change that to 3 minus and hit enter. And it's negative 0.618. Okay, so those are the two times. Well, we can't have a negative time. That does not make sense. That's an extraneous solution. So in the context of this problem, we don't want the negative. So at approximately 6, so at time at approximately 6.1 seconds, the ball landed on the ground. Okay, so part E is right here. It says, what is the maximum height that the ball reaches while in the air? How long will the ball take to reach its maximum height? So what I'm going to do is I'm going to erase all of this. I'm going to show you quickly why I'm doing that. Okay, I'm going to get rid of this here. So I'm going back to the equation that we had. Alright, and then I just want to move that out of the way. Alright, so we have negative 16 times t minus 3 squared equals negative 150. To put that in vertex form, which we learned in the last section, it would be negative 16 t minus 3 squared. Move this 150 back over here, and it's positive 150 equals 0. So now that this is in vertex form, remember, my point is this and this in parentheses. So the answer is, and it's the opposite because it's inside parentheses, 3 comma 150. So what that means is after 3 seconds, the ball went up 150 feet. So vertex form is nice in using and finding the maximum or minimum because the vertex is at a maximum or a minimum of a parabola. And doing this problem using completing the square puts it in vertex form, so we killed 2 birds with 1 stone. Okay, page 2. Part F. What features of the quadratic function are visible since it is presented in the standard form f of x equals ax squared plus bx plus c? Okay, on to page 2. Part F. What feature or features of the quadratic function are visible since it is presented in the standard form? Okay, so, well, if a is positive, then we know it opens up. If a is negative, we know it opens down. C is our constant, so we know the value when x is 0. The constant would be the y value. And we also know that, oh, what else? We know if the function is going to be wider or narrower than the graph of f of x equals x squared. Okay, so here it is in words. We can see the initial position or height of the ball, or the height when t is 0, and that is our c. Okay, c tells us that in the constant term, c. We can also see the leading coefficient, which tells us about the end behavior and whether the graph is wider or narrower than the graph of f of x equals x squared. So if a is greater than 1, then it's narrower, and if a is between 0 and 1, it's a fraction, it's going to be wider. A is positive, it opens up. A is negative, it would open downward. Okay, part G. Okay, G, what features of the quadratic function are visible when it is rewritten in the vertex form? Okay, well, our HK is our vertex. Okay, so we can only see the coordinates of the vertex and know that x equals h is the equation of the axis of symmetry. So let me just bring that in. Okay, so we can only see the coordinates of the vertex and know that x equals h. So x is my h is equal to the axis of symmetry. Okay, the vertical line that it reflects across. We can still see the leading coefficient in this form, which tells us about the end behavior and whether the graph is wider or narrower than the graphs of f of x equals x squared as well. Okay. Okay, now it says a general strategy for graphing a quadratic function from the standard form, and there's different things we need to do. And the first one is we need to look for hints in the function's equation for general shape, direction, and y-intercept. Okay, we need to solve f of x equals 0 to find the x-intercepts by factoring, completing the square, or using the quadratic formula. We need to find the vertex by completing the square or using symmetry. Find the axis of symmetry and the x-coordinate of the vertex by using negative b over 2a, and the y-coordinate of the vertex by finding the f of negative b over 2a. In other words, you find negative b over 2a, and then you take that value and you substitute it in for x to find your y. And finally, you need to plot the points you know. At least 3 are required for a unique quadratic function. Sketch the graph of the curve that connects them and identify the key features of that graph. Okay, example 1. A high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t equals negative 16t squared plus 96t plus 6, where t represents time in seconds since the ball was thrown, and h represents the height in feet of the ball above the ground. So this is the same example as the first page. So now it's saying, what do you notice about the equation just as it is that will help us in creating our graph? Okay, so the first thing I want to look at is the leading coefficient is negative. So we know the graph will open downward. So we know the graph is going to look like this. Okay, that's one thing. H of 0, in other words, when t is 0, we'd get 0 plus 0 plus 6. H of 0 is 6. So that is going to start us out at, if we were to graph this, we would go up to 6, and our parabola would do that, starting at 6 on the y-axis. So that point is the point 0, 6. So that's our y-intercept, the constant. Okay, now it says, can we factor to find the zeros of the function? If not, solve h of t equals 0 by completing the square. So since we already completed the square, and the zeros are irrational and more difficult to work with, we can easily find the vertex using the completed square form. And I will just write that down here. I'm not going to do it again. It was done on page 1. So we're going to get, okay, I pressed the green ink and it's still red. So we're going to get h of t equals Okay, and if I went back to the prior page, then it should be, I think I erased it. I did. All right, but it's h of t equals, should still be my calculator. There it is, 6.0618 and negative 0.618. Okay, so that would be 6.06 comma 0 and negative 0.06 comma 0. Those would be the two x-intercepts. All right. Okay, on to page 3, part C. Alrighty, now it says, what is the vertex of the function? What method did you use to find the vertex? So I brought in the equation from the question. I copied it, and then I wrote down how we completed the square, and this is the equation of the completed square. So to find the vertex, obviously if you use vertex form, it's staring you right in the face. So there it is, right there. The vertex is 3, 150. Okay, what is the vertex? 3, 150. Now, if you didn't do completing the square and you wanted to know what the vertex is from here, then you say x equals negative b over 2a, which equals negative 96. So b is 96, so it's negative 96 over 2 times negative 16, or negative 32. And that equals 3. Negative divided by negative is positive. 96 divided by 32 is 3. So there's my 3. Then what I would have to do is find h of 3. I'm not going to go through all of that, but you do h of 3 equals negative 16 times 3 squared plus 96 times 3 plus 6. And when you do that, you would get 150. So there's a little bit more work required here. If you've already got it in vertex form, it's staring you right in the face. All right. Okay, so from part A and B from the prior page, we know that the zeros were negative 0.06 comma 0, and the other one was 6.06 comma 0. So if this were 1, 2, 3, 4, 5, 6, I would be just to the right of it right here, 6.06, and negative 0.06 is really, really close to 0, so I'll just put it right to the left of that origin. So there are my two zeros. Now I need one more point because it says at least 3 points to graph, and I have the third point right here, my vertex. So if I went over 1, 2, 3 and up to 150, so let's just say this line right here was 150, then I go over 3 and up 150 would be right here, and then I would draw my parabola like so. Okay, this is really difficult to do with the pen and the pad that I use here. So anyhow, you get the idea. So this would come. Oops. Whoa. How about Control Z? That was really bad. All right, try again. So this is going to come up, curve around, and then come down through like that. Okay, pretty sloppy, but there you go. That is what the parabola would look like with these two zeros and this maximum at the vertex. On to page 4, exercise 1. It says now graph this function and identify the key features. Okay, well, key features. My constant is my y-intercept, so that's a key feature. So the y-intercept equals, I'm not going to use the equal sign, the y-intercept is the point 0. When x is 0, y is 5. Okay, so there's 1 point I can graph. Over 0, up 1, 2, 3, 4, 5. So I put a point right there. There's my y-intercept. Okay. Next thing we can do is find the vertex. The vertex is either going to be from vertex form or using negative b over 2a. So since this is in standard form, I will just do negative b. So I'm going to write it over here. A, in this case, is 1. The leading coefficient is a 1. B equals negative 6. And my c, my constant, was 5. So x equals negative b over 2a equals negative 6, which is 6, over 2 times 1, which is 2. So my x value is 3. So now I know that I have a line of symmetry. Let's do it this way. So my line of symmetry is at 3. That's a little thick, so I'll fix that and make it this. Okay, that's better. So there's my axis of symmetry, x equals 3. So I know it's a reflection. So with that fact, I know that I'm 1, 2, 3 units from my axis of symmetry for my y-intercept. So if I go over 1, 2, 3 more this way, there's another point on my parabola. And my a is positive 1, so that means it's opening up. So it's going to curve this way. So if I find the vertex and maybe some y-intercepts, then I have plenty of points to graph. So my vertex x value is 3. So now I want n, right? Our function here is n of x. So I want n of 3 equals 3 squared plus, just kidding, minus 6x, or in this case 6 times 3. I'm not going to write the formula again. I'm just going to substitute 6x plus 5. So my n of 3 is going to equal 9 minus 18 plus 5. So my n of 3 is going to equal negative 9 plus 5, which is negative 4. So my vertex is 3, negative 4. So it's 1, 2, 3, 4. So it's right here. Okay. I have enough points, but we want to find the x-intercepts. And there are going to be 2, because it's a parabola, and we know that it's not a double root, so it's going to cross 2 locations. So the x-intercepts can be found by factoring. So let's factor this. I'll use green so we can see what's going on here. So we have x squared minus 6x plus 5 equals 0. That looks like less than because it snapped. Okay, so let's just rewrite that. 5 equals 0. So I'm looking for factors of 6, or factors of 5 that add up to 6. Well, it's minus 1 and x minus 5. Negative times negative is positive 5. X minus 5x and minus 1x is minus 6x. So in this case, x equals 1 when we set each of these factors equal to 0, or x equals 5. So now I have my x equals 1 or my x equals 5, and obviously it's a y-intercept, so my y is 0. So I have the point 1 right here, and 5, which is right here. And then finally we're going to draw the parabola coming down. Okay, curving around, coming back up, and something like that. So there's my graph. And these are the key features. Y-intercept, vertex, x-intercepts. Okay, here's number 2, exercise 2. So hopefully you tried this on your own. Pause the video, see if you can do it, and then we'll go from there. All right, so here we go. So we have 1/2 x squared plus 5x plus 6. So the easiest thing to do first is your y-intercept, which is 6. So it's when x is 0, y is 6. And that's the point 1, 2, 3, 4, 5, 6. And that is right here. Okay? That's done. Next, we want the vertex. So a equals 1/2. B is equal to 5. And C was 6. So I do x equals negative b over 2a. So I'm going to write the formula every time, that way we remember it, which equals negative b, which is negative 5, over 2 times 1/2. Well, that's just 1, so that's negative 5. So my vertex is negative 5, comma, f of negative 5. What was that? Malfunction. F of negative 5 equals 1/2 times negative 5 squared plus 5 times negative 5 plus 6. So that's going to equal negative 5 squared is 25. Half of 25 is 12.5. Negative times a positive is negative, so it's minus 25. Plus 6. So f of negative 5 equals 12.5 minus 25 is negative 12.5, plus 6 is negative 6.5, or 6.5. So I'm going to write that here, negative 6.5. So I go left 5, down 1, 2, 3, 4, 5, 6.5. So my point is right there. There's my vertex. And if I draw a line, and let's make it like this and red. Actually, let's make it green this time because I'm using a red dot, and we draw it. So let's just do a vertical line and then just move it over to there. Okay, there's my vertex, or my axis of symmetry. Okay, so x equals negative 5. Now I just need the x-intercepts. All right, so if I look at this, this half here is making it difficult to factor. So how about we just complete the square? All right, so completing the square would be okay, so I worked completing the square behind the scenes on a piece of paper, and it was pretty ugly. So I changed my mind. I'm not going to complete the square for the video. I'm going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So over here, that's why I like listing my a, b's, and c's. Now I can just do substitution. Negative 5 is my negative b. Negative 5 plus or minus the square root of b, 25, or 5 squared is 25, minus 4 times a, which is 1/2, times my c, which is 6. Okay, so this is all over 2a. Well, 2 times 1/2 is 1, so that just means I don't have a fraction. So the answer is negative 5 plus or minus the square root of 25 minus, well, 4 times a half is 2. So this is 2. 2 times 6 is 12. 25 minus 12 is 13. So my x-intercepts are negative 5 plus the square root of 13, comma, 0. My other one is negative 5 minus the square root of 13, comma, 0. Okay, now that it's irrational, I see why I didn't want to complete the square. So there you have it. Now we're going to graph these. If I put that in my calculator, negative 5 plus the square root of 13. I'm just doing an approximation here. Negative 5 plus the square root of 13 is negative 1.39. Okay, so negative 1.39. So that is, I'll use red because that's what I've been using. That is about right here. Okay, and then if I do it again, but put minus the square root of 13, I get negative 8.60. So that will be negative 1, 2, 3, 4, 5, 6, 7, 8 point something. So it's right around here. And then we could also go over 1, 2, 3, 4, 5 to my axis of symmetry. 1, 2, 3, 4, 5 to here. So then when I draw this, ooh, this is hard. Okay, and then something like that. So there is the graph of my parabola. Okay? And there are the 3 key elements.
Okay, this is page 5. Speaking of Paige, Paige wants to start a summer lawn mowing business. She comes up with the following profit function that relates the total profit to the rate she charges for a lawn mowing job. And she came up with P of x equals negative x squared plus 40x minus 100. Now keep in mind we're looking for 3 things. The x-intercepts. We're looking for, let me use a colon here. We're looking for y-intercept. And we're looking for the vertex. So I am not even going to begin graphing this until I find the vertex and y-intercept, because that will help me determine how to graph and what unit of measurement to use. So the vertex, or the y-intercept, is the easiest. So whenever I plug in 0 here and here for x, 0 squared, negative 0 squared plus 40 times 0 is just simply 0, and we get the y-intercept being the constant. So the y-intercept is 0, comma, negative 100. Okay, so now I don't want to name these, number these 1, 2, 3, 4. Okay, 100, negative 100 would be way off the graph. So there's an indication there. There's our negative 0, negative 100 is our y-intercept. Okay, so I put in the x and y axis, and I know my y-intercept is negative 100, so I'm going to start it down here. That is how I started this graph. So I'm not going to go below my y-intercept because I know that a is negative, and therefore that means the parabola opens down, so there's a maximum. So I know it's going to go up this way and then curve back down. Okay, so that's why I put the y-intercept at the lowest corner here. Okay, so now we need to find the vertex. The vertex is x equals negative b over 2a. So therefore my vertex is negative b over 2a, comma, the function value at that point, or at that x value. So negative b is negative 40, because b is 40, over 2 times a, which is negative 1. So it's negative 40 over negative 2. Negative divided by negative is positive. 40 divided by 2 is 20. So that is my x value. So x equals 20. Once I find that x value, I substitute it into here. So then I want to find f of 20. So, or p of 20 in this case. So p of 20 will be my y value of my vertex. So it would be negative 20 squared plus 40 times 20. Running out of room here. Minus 100. So 20 squared is 400, so that's going to equal, so p of 20 equals negative 400 plus 40 times 20 is 800 minus 100. So negative 400 plus 800 is 400 minus 100 equals 300. So p of 20 is 300, so that is my vertex. Okay, so my vertex is 20 comma 300. So now I know that my vertex is a maximum, and if I want this centered somehow, 5, 10, 15, 20 could be here. We could go by 5s. So if I make that 20, let me use black. 5, 10, 15, 20 is here. 25, 30, 35, 40 is here. And we'll go from there. So I know I have the point 20, 300, which is up here. This is 200. 300 is right at the top here. I just didn't write that in yet. So there's 300, 100, 200, 300. I went in increments of 25 on the y-axis and 5 on the x-axis. So my vertex is the point 20 comma 300. So if it is down here at negative 100, and remember that my line of symmetry, we do a segment, dashed, and how about, whoops, a segment, dashed, a little bit thinner, and make it red, and that would go right here. There's my vertex, x equals 20. And I put it at 30 for some reason, so let's move that over here. There's my vertex. So there's the maximum. So what I want to do is draw a parabola, and it's going to go up, curve, come back down. So since this is 20 units from my vertex, and I go over 20 because it is symmetric, then my point would be here. So I know that this is going to curve up, around, and back down. Let me try to draw that. Okay, so here's my parabola. And now I need to find this point here. There is one solution, or x-intercept, and here's the other. Just a little less than 40 and a little more than 0, but we need to use the quadratic formula to do this. So it's going to be x equals negative b plus or minus. Let's try that again. Plus or minus the square root b squared minus 4ac all over 2a. X equals negative b. B is 40 plus or minus the square root of b squared, 40 squared, 1,600 minus 4. Okay, just had to move that over a little. Negative 1,600 minus 4 times a, which is negative 1, times c, which is negative 100. All over 2 times a, which is negative 1. So that's going to equal negative 40 plus or minus the square root. Now this is 1,600. Minus times a negative is positive, times a negative is negative. So it's 1,600 minus 1 times 4 times 1 is 400. All over negative 2. So my x is going to equal negative 40 plus or minus the square root of 1,600 minus 400 is 1,200, all over negative 2. Okay, now I can simplify this. So if I'll move over here, the square root of 1,200 is 2 times 600, which is 2 times 300, which is 2 times 150, which is 2 times 75. Okay. Okay, I just got that text out of the way. So I got to keep going when this, now 2 won't go into this, but 5 will. 5 goes into 7 once, 5 goes into 25, 5 times, 15, and then 3, or let me just put it as 5 times 3. Okay, so we have a pair of 2's, we have a pair of 2's, we have a pair of 5's. 5 times 2 is 10, times 2 is 20. So this is going to simplify to x equals negative 40 plus or minus 20 square root 3 divided by negative 2, which is going to equal x equals 40 divided by 2 is 20. Negative divided by negative is positive, so it's 20 plus or minus 20 divided by 2 is 10 square root 3. Okay? Okay, so I'm just going to move this over here. So this is the point 20 minus 10 square root 3, and this is the point 20 plus 10 square root 3. Okay, part B says, according to the function, what is her initial cost? For example, maintaining the mower, buying gas, advertising. Explain your answer in the context of the problem. Okay, so in other words, what that means is, initial cost is when she hasn't mowed any lawn. So if we plugged in 0 here and here, in other words, the y-intercept. If I mow 0 lawns, I make negative $100. So her initial cost is $100 because that's her y-intercept when x is 0. When she's mowed no lawns, she has spent $100 getting started with the lawnmower, the gas, and the advertising. Okay, part C says, between what 2 prices does she have to charge to make a profit? Okay, so in the context of this problem, profit means y is greater than 0. In other words, whenever she's above the x-axis. So she's not making any money here, 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 but then right here is break even. Now she's profiting, now she's profiting. This is maximum profit. And then if she mows more lawn, she starts to lose money. And then all the way down to break even again. And then going down into the red again. So we need to find the values of our intercepts. They are, okay, so I need to plug in the x-intercept, 20 plus or minus 10 root 3, which we solved by doing the quadratic formula, or you could have completed the square as well. So anyway, I just need to find out what this value is in dollars. We don't use radicals for money, so I will get my calculator, and I will put 20 plus 10 square root 3. Enter. And then I'll just do second entry and change the plus to minus. And there's my plus or minus values. Okay. So since the question's about money, we will approximate it, and it will be between what 2 prices will she have to charge to make a profit. So if she charges $2.68, she'll break even. So it'll be between $2.68 and $37.32. Okay, this is a really good problem to figure out. Why would charging more money not make you more money? Well, if you charge too much, you go to someone's house, say, I'll mow your lawn for $50, and they're going to say, no, thank you, and you make $0. So there's going to be a point where people are not willing to pay high prices, so you have to find the best price to charge, and that would be when X is 20. So if she charged $20, that's where she'd make the most money. She charges more than $20, she'll mow less lawns and make less money. Okay, part D says if she wants to make $275 profit this summer, is this the right business choice? So you look at the graph, what's the maximum? The maximum is $300. $275 profit would be 225, 50, 75. So the answer is yes. Okay, the answer is yes. Looking at the graph, the vertex 20, 300 is the maximum. So if Paige charges $20 for each lawn she mows, she can make a $300 profit, which is $25 more than she wants. So if she wants to make $275 profit this summer, here's another way of looking at this. $275 is right here or right here. Okay, I personally would want to stay on the left side of the axis of symmetry because less lawns making the same amount of money as more lawns. I'd rather do less work for the same amount of money, correct? So this is 15, this is 10, so it looks like about 13 lawns will get her $275 profit. Okay, on to page 6, number 4. A student throws a bag of chips to her friend. Unfortunately, her friend does not catch the chips and the bag hits the ground. The distance from the ground, height, for the bag of chips is modeled by the function h of t equals negative 16t squared plus 32 plus 4, where h is the height, distance from the ground in feet, of the chips, and t is the number of seconds the chips are in the air. Now it says to graph the function h. Okay, so in order to graph, we need, in this case, we're not talking about x, y, so it's h and t. So the t-intercept, so in this case, t is our independent variable, and h is our dependent variable. So if we want to know 3 things, that is the vertex, that is a point. We want to know the h-intercept being the y-intercept. And the h-intercept is just when x is 0. Or in this case, when t is 0, then our constant is our t-intercept, 0, 4. Okay, that's the easiest one to do. The next thing we have to find, as well as the h-intercept, are the t-intercepts, or the solutions to the problem. Same as the x-intercept in an xy function. Okay, so there's 2 of those. So I'll just set this up like this, and we'll fill it in as we go. So we already know the h-intercept is 4. And let's go by 2's. So this is 2, here's 4. So here's 4. And I'll just put a mark here and say 2. So we know that's 2, 4, 6, 8, and so on. Okay, so the h-intercept is 0, 4. We know that a is negative. This negative right here tells us the parabola is going to look like this. So we know the shape of the parabola just by a, opening down. Okay, so the next thing we need to do is find the vertex. The vertex is x equals negative b over 2a. And I'm using the term x here, but actually x is considered t in this case, so I should just stick with the proper variables. So our t is negative b over 2a. So our t is going to equal negative b, which is 32, negative 32, divided by 2 times a, which is negative 16. Okay, well that's going to equal a negative over a negative is positive. 32 divided by 16 times 2, which is 32. 32 divided by 32 is 1. So I know that my vertex is the point 1, comma, h of 1. So now I just need to find h of 1, which equals negative 16 times 1 squared plus 32 times 1 plus 4. So my h of 1 equals 1 squared is 1 times negative 16 is negative 16 plus 32 times 1, which is 32, plus 4. Well, negative 16 plus 32 is positive 16 plus 4 is 20. So my vertex is the point 1, comma 20. So if I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 is right here, and it's over 1. And just so this isn't squished, this is 1/4, 1/2, 3/4. Let's call each 4 1. So there's 1. So I know my vertex is the point 1, comma 20, and that will be right here. I will draw a segment showing the axis of symmetry. And let's make it red. And it is going to be at this location right here. Let's make that a little thicker. That's better. Okay, so there's my axis of symmetry. 1, x equals 1. My vertex is the point 1, comma 20. So now I can draw a function through that point, but let's plot another point. So if this is the point 0, 4, then I go over 1, 2, 3, 4 units, which are quarters. So there's 1, 2, 3, 4 to here, that would be 2. So there's a value here. Now if I draw an arc, let's make it green, from here to here, going through there. Okay, that's approximately what our arc would look like. But it's going to continue down because we have to have it cross, so let's just continue that. So this is going to continue down. I don't want to do that. It's not straight. I just want to draw it. So this would continue down this way, and this would continue, oops. This would continue down this way to negative infinity. We need to find the 2 intercepts here. In order to find the intercepts, I find it easiest to either complete the square or do the quadratic formula. I will do the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4 ac all over 2a. So x equals a negative 32 plus or minus the square root of b squared. Well, what is 32 squared? (1024) minus 4 times a, which is negative 16, times c, which is 4, all over 2 times my a, which was negative 16. Okay, simplify this. Negative 32 plus or minus the square root of 1024. And now to negative times a negative, which is positive, times another positive is still positive. And 4 times 4 is 16. And 16 times 16 is 256. Divided by 2 times negative 16, which is negative 32. Okay, so now I'm going to simplify this, and I'm going to get negative 32 plus or minus the square root of 1024 plus 256. 6 plus 4 is 10. Carry the 1. 5, 6, 7 plus that 1 is 8. 2 plus 0, and then 1 all over negative 32. Okay, now I just need to simplify 1280 square root. I'll do that over here. So actually, let me erase all this. And we'll start at the top here. Negative, no, not negative, 1280. And I'm going to simplify the radical by factoring. That would be 640. Divided by 2 is 320. Divided by 2 is 160. Divided by 2 is 80. Divided by 2 is 40. Divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. So I have a pair of 2's, another pair of 2's, another pair of 2's, and another pair of 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to equal negative 32 plus or minus 16 square root of my leftover 5 all over negative 32. So I'll move that up here. Negative divided by negative is positive. 32 divided by 32 is 1 plus or minus. And 16 divided by 32 is a half, so I can write this as the square root of 5 over 2. So my x-intercepts, or my t-intercepts, are 1 plus the square root of 5 over 2, comma 0, and 1 minus the square root of 5 over 2, comma 0. And those are these two values here. Okay? Okay, B says, from what height are the chips being thrown? Well, the chips start at time 0, and the height was 4. So they're being thrown from 4 feet. Tell how you know? You know from time being 0. They're in the person's hand at time 0. If you're going to time a throw, as soon as you throw it, the timer starts. So if the timer's not starting, we're at 0 time. And when I plug 0 into this function, I get the constant 4. So it's 4 feet. Okay, now it says, what is the maximum height the bag of chips reaches while airborne? Tell how you know. And the answer is 20 feet. Wow, she really threw it up there. Okay, right here is my maximum. And that is the y value of the vertex. And that is how we know. Okay, part D says, how many seconds after the bag was thrown did it hit the ground? Okay, well, we have to go back up here. And it hit the ground. That's where our solutions come in. That's where our t-intercepts tell us. So it hit the ground. So it started here at 4 feet in the girl's hand. She threw it and went all the way up to 20 feet after 1 second. And then it came down and it was here at 2 seconds, but it was a little more than 2 seconds. And the answer is right here. So how many seconds after the bag was thrown did it hit the ground? 1 plus the square root of 5 over 2 seconds, if you will. But I will use the calculator because no one knows what that means if you said that. So it'd be 1 plus the square root of 5 divided by 2. And I need a parentheses here. Okay, so we're taking 1 plus the square root of 5 halves. And the answer is 2.12 seconds. Approximately, if I had to round, 2.12 seconds. Okay, so on to page 7. Part E. What is the average rate of change? Average rate of change of height for the interval from 0 to 1/2 second. What does the number represent in terms of the context? Okay, so first of all, we need to know what average rate of change is, and that is f of b. The function at b, and this is our b, this is b right here, 1/2, minus f of a, which is 0a, all over b minus a. So that's going to equal f of b. Now we need to go back to the equation. Let me get that. Okay, so I brought the equation in here. It is this right here. So f of b would be plugging in 1/2 to here. So this is going to take a little bit of room, so let me move this down. Okay, so I'm going to take this function with 1/2 substitute into it. So it's going to be, let me use parentheses. It's going to be negative 16 with 1/2 substituted in for t, plus 32 with 1/2 substituted in for t, plus 4. We're going to take all of that and we're going to subtract f of a, which is f of 0, and that would just be our y-intercept because 0 substituted it in here and here. These cancel and we're just left with 4. So I'm not going to spend the time doing that. All over b, which is 1/2, minus a, which is 0. So now we just need to simplify this. So negative 16 times 1/2 squared. 1/2 squared is 1/4, and negative 16 times 1/4 is negative 4, plus 1/2 of 32, which is 16, plus 4, and then we have this minus 4 out here. So that's all over 1/2. Well, that is going to equal negative 4 plus 16 is 12. Plus 4 minus 4 we can just ignore. And 12 divided by 1/2. So it's 12 over 1/2. Well, that's the same as 12 times 2 over 1, which equals 24. Okay, so that means the rate of change for the interval from 0 to 1/2 is 24 feet. Okay, we're talking about feet. So it's 24 feet per second. Oops, right here. 24 feet per second. Okay, so then it says, what does that number represent in terms of the context? So it represents the average speed of the bag of chips from the time 0 to 1/2 seconds. Okay, part F says, based on your answer from part E, what is the average rate of change for the intervals from 1.5 to 2 seconds? Okay, so we just did 0 to 1/2. Now they're asking 1.5 to 2. So if I go back to our graph, oh, the graph is gone. I went back to our graph, and it's not there. Okay. Okay, so we're going from 0 to 1/2, and we got 24 feet per second. And now they're saying, based on your answer from part E, what is the average rate of change for the interval from 1.5 to 2 seconds? So if I do go back to the graph, I brought that in. So we just did 0 to 1/2. So the rate of change from here up to here was 24 feet per second. Now they're saying, what would it be from 1.5 down to 2 seconds? So this one is going this way, and this one is going this way. Same distance, mirror image, so guess what the answer is? Well, the answer would be negative 24 feet per second, meaning it's dropping 24 feet per second. Notice how the profit and height functions both have negative leading coefficients. Explain why this is. I will just bring that in, and that is because the nature of both of these contexts is that they have continually changing rates, and both require the graph to open down since each would have a maximum. Problems that involve projectile motion have maxima because an object can only go so high before gravity pulls it back down. Profits also tend to increase as prices increase only to a point before sales drop off and profits begin to fall. Okay, that brings us to page 8, and that brings us to the end of lesson 17. Review the lesson summary and go to your problem set.